is freeze-drying microscopy. To understand what freeze-drying microscopy is, we first need to understand what is freeze-drying or lyophilization. Well, freeze-drying is a method of preserving perishable wet materials like foods and pharmaceuticals so that they can be stored or more easily transported without microorganisms turning them nasty. But it's also been used for other applications that require the removal of water. For example, it has even been used to dry out books rescued from flooded libraries. The basic process involves freezing the material well below the triple point. This is the temperature at which solid, liquid and gas phases can coexist. The temperature must be brought down well below this point to ensure complete freezing, because if there is any part of the material still liquid, it will destroy the structure when the drying begins. The pressure around the material is then lowered so that the ice sublimates directly from the solid phase into gas phase without becoming liquid. As the ice leaves the material, the structure is left behind intact. Freeze-drying is an expensive process. In order to maximize the yield of the product, scientists can investigate the ideal conditions by recreating a freeze-drying cycle on a microscope using a mini version of a freeze dryer. There are 4 distinct steps in freeze-drying. Pretreatment. This may include concentrating the product, reformulating or adding components in order to increase the yield, the quality, and the appearance, but also to increase the temperature of drying and reduce the cycle time. As industrial freeze dryers use tons of liquid nitrogen to cool the samples, increasing the temperature that the dryers run at by as little as 1 degree can save lots of money. Freezing. The size of the ice crystals can have a significant effect on the quality of the freeze-dried product. Large ice crystals can be more easily dried due to creating largely open structures with large paths for the vapor to escape. But in forming these large crystals, biological material can be destroyed. By using the freeze-drying microscope, it is possible to investigate how rates affect the crystal size and so improve the quality of the dried product. Primary drying. During this step, the pressure in the drying chamber is lowered and a very small amount of heat is applied to the sample. This part of the process can take days in an industrial drying cycle, as if too much heat is applied, the structure may be altered or destroyed. If drying time can be reduced, there is another opportunity to reduce costs. Secondary drying. During this phase, there is a final attempt to remove remaining water molecules, since all the ice should have been removed in the primary phase. Pressure is usually further reduced and the temperature increased. So, as we can see, a freeze-drying microscope is a pretty useful bit of kit for the scientists trying to optimize their freeze-drying cycles. To find out more, please visit lincam.co.uk.